Good morning, college algebra class. I apologize for not being there today. Had to stay at home, top secret stuff. So, anyway, I thought I would guide you along your problems today. This is following what we were doing yesterday with expanding and condensing logs using the three properties that we talked about. All right, let's look at the first one. All right, in 57 here, this is on page 457, 458. I'm asked to condense these two logs into a single log. Now, if you notice here, they both have the same base, which is necessary for you to condense. Since they're both added, I can create just one log multiplied. Log base 5 of u times v. Now, don't forget that this 4 and this 3, since they're on the outside, they're in front of the logs as coefficients, when I condense, they will go back inside and become exponents of the two factors u and v. So when I condense this, the final answer is log base 5 of u to the third times v to the fourth. All right, taking a look at 59, condensing these, since they're subtracted, I'm going to have a single log base 3, but this time I'm going to have a fraction. In this problem, the square root of x will go on the top, and x cubed will go on the bottom. Why does x cubed go on the bottom? Because of that negative sign right there. Okay? When you have that negative sign, don't forget that argument goes to the bottom of the single log. So the final answer is log base 3 of square root of x over x cubed. All right, in number 63, taking a look at this one, I've got the natural log, but at this time I've got three natural logs. So when I condense, I'm going to condense into a single log. There's one log that's being subtracted, so I know there will be a fraction in the final answer. On the top, I'm going to go x over x minus 1. I don't know what happened there. X times x minus 1 times x plus 1 over x over, that becomes x squared minus 1. Okay? Now, if you look inside of this argument, there's some algebra that we can do. I can cancel out this x up here and this x down there, and this x squared minus 1 on the bottom. This guy right here, he can factor. So I'm going to get ln of, that would become x plus 1 over x minus 1 over x plus 1, x minus 1 factored. Now, from here, I can multiply by the reciprocal, because really, if you look at this, this is just two fractions being divided. On the side here, I've got x plus 1. I don't know what's going on, sorry. X plus 1 over x minus 1 times the reciprocal of x plus 1 times x minus 1 would be 1 over x plus 1 times x minus 1. Now, if you notice, I can cancel out the x plus 1 and the x plus 1, and that gives me just 1 over x minus 1 squared. So the final answer to this is natural log of 1 over x minus 1 in parentheses squared. Okay, the next problem that we want to look at is going back to 61. This one will be the log base 4. Because this is a subtraction and I'm going to have a fraction of x squared minus 1 on the top over x plus 1 to the fifth on the bottom. Okay? And we'll call it a day on that one. All right, you could simplify, but I won't require you to simplify that problem. All right, and then let's take a look at the next problem here. All right, number 65. Let me erase some of this old work. So we have space over here. Let me just, ooh, hello. Sorry about that. All right, let's try this again. Okay, let's move this around a little bit. And take a look at number 65. Right, 65 says I've got log base 2, so I know when I condense, it'll be a single log of log base 2. There's a negative log here, so it's a subtraction. The square root of 3x minus 2 goes on the top because he's a positive log, but he also has an 8th power. We'll talk about that in a second. Times this 4 goes inside of here, right? And then I've got 4 over x that goes right here. Now, if I simplify this, first of all, a square root raised to the 8th power is like saying a half times 8. So that becomes log base 2 of, well, that becomes 3x minus 2 to the 4th power times 4 over 4 over x. But just like in number 63, when I divide a fraction by another fraction, that's like multiplying by the reciprocal. What you're going to notice is I've got 3x minus 2 squared, or I'm sorry, to the 4th, times 4, times the reciprocal of 4 over x is x over 4. So now notice this 4 and this 4 will cancel. And so my final answer will be log base 2 of 3x minus 2 to the 4th times another x. And big parentheses there. And that's your final answer on that one. Okay, let's go to the next problem. Moving down. Actually, I'm going to skip down to these. In 71 through 78, there's a new idea. It's called the change of base formula. It's for use on our calculators. If you look on your calculator, you only see 2 buttons. You'll see a basic button that says log, and right below that, you'll see a button that says ln. So there's only 2 buttons, or 2 types of logs that your calculator can handle. A base 10 log and a base E log. Because again, that's what a log with no base means, and that's what a ln means. So what that means is, if we want to have, like in 71, if I want to find out what log base 3 of 21 is, that says 3 to what power equals 21. Well, that's a problem we can't do in our heads. That's a problem we're going to need our calculator for. So if I want to do this problem on our calculator, then what I have to do is use the change of base formula. The change of base formula says if I have log base b of some argument a, I can change the base that's now b into, say, the common base. So log base 10 of the argument divided by the log base 10 of the base b. So it's the common log of the argument divided by the common log of the base. Little concept for you, the way I think about it, if I have this, all I do is draw a line underneath the log of A and write the word log next to B, and that gives me that change of base right there. So if I wanted to do this on my calculator, if I had, say, log base 3 of 21, and I needed to type that in on my calculator, I can type that common log button of 21 divided by the common log of 3, and when I do that, hold on just one second, I get the answer of common log of 21 divided by the common log of 3, 2.77 rounded, so approximately 2.77. And that's how you use the change of base formula. Okay, that's it for now. Hopefully this is helpful to you. Probably, a lot of you say it won't, and you'll judge me harshly, but, what can we do? I'm sitting at home drinking coffee. All right, guys, I'll talk to you later. I'm rambling at this point, so